Welcome back to The Explainer. Today we're doing something a little different. We're not just taking a walk through history, we are going to reverse engineer a literal mountain. Imagine trying to design this massive, load-bearing monument with absolute, flawless mathematical precision. Okay, now imagine doing it entirely with computers, without a single drop of mortar, and, here's the kicker, without the ability to fix even a single mistake. That is the raw cinematic reality of the Elephanta Caves.
Okay, let's dive right into this. We're looking at Gharapuri Island, just off the coast of modern-day Mumbai. Now, to a casual observer, it just looks like this lush, beautiful island getaway, but geologically speaking, it is an incredibly hostile canvas. This place was formed millions of years ago by the intense volcanic activity of the Deccan Traps. So the ground beneath those trees isn't nice, soft earth. It is solid, unforgiving basalt rock. And it was right into this raw, dense volcanic stone that ancient engineers decided to, well, carve a universe.
To really wrap your head around the sheer scale of what they actually accomplished, just think about this number, 20 feet. That's, roughly the height of a two-story building. And it happens to be the towering height of the colossal bust housed deep within the main cave. But we really need to look at this as more than just beautiful ancient art. It was a massive load-bearing challenge. Carving a structure this huge out of living rock means you're dealing with thousands of tons of pressure from the mountain pushing directly down on top of it. So that 20-foot, two-story colossus, that is the Trimurti Sadashiva, which depicts three different aspects of Shiva. On the right side, you've got Vamadeva, the gentle preserver. On the left, Aghora, the fierce destroyer. And right in the center, Tatpurusha, the serene creator. To create these insanely dynamic, deep relief faces, the artist had to carve recessed panels up to 2 meters deep into the back wall. Think about the engineering stakes here. If they struck just a little too hard or miscalculated the stress points of the wall while hollowing out these deep cavities, no way around it. The entire back face of the mountain could have collapsed right in on them. So the absolutely crucial point here is understanding the madness behind their method. Monolithic, rock-cut architecture. Look, this isn't building. This is excavating. You're not taking blocks of stone, hauling them over, and stacking them up with mortar to build a temple. You are doing the exact opposite. You're starting with a solid mountain and taking material away. It's kind of like trying to 3D print a masterpiece, but entirely in reverse and blindfolded by a literal mountain. Why does this matter? Because in subtractive architecture, there's no undo button. A single math error, one misplaced stripe of the chisel, and the whole shebang is ruined. It could never, ever be fixed. So to pull this off without getting crushed, these ancient architects needed a flawless plan. Just look at the layout of Cave 1, the Great Cave. Picture this as a glowing 3D holographic blueprint projected right into the pitch-black heart of the mountain. We're not just looking at some random holes dug in the rock. This is pure cosmic geometry. The cave goes an astounding 39 meters, nearly 130 feet deep, opening into a 27-meter square main hall. It's a highly sophisticated, symmetrical grid that was literally designed to represent the universe itself. And that magnificent blueprint all boils down to the number 36. The floor plan is perfectly divided into exactly 36 symmetrical bays. The underlying math is a perfect 5x5 square of smaller bays, representing a sacred mandala. But they didn't just stop at a basic square. To create this stepped, visually complex outline with 12 distinct corners, they added triple bait extensions on all 4 sides. Just think about that. Every single pillar, every single gap in the wall, had to be completely mathematically mapped out in their heads before a single stone was struck. Now, what's really fascinating about this slide is how that math dictates your physical experience in the space. The engineers designed this brilliant dual-axis alignment. One axis flawlessly connects the east and west entrances, and it pulls your eye straight to the displaced Linga shrine. Shifting that shrine away from the dead center was actually a deliberate architectural genius move. It opened up a completely clear north-south pathway right to the major sculptural panels. They literally engineered your line of sight as perfectly as they engineered the stone. Okay, but how do you actually carve a 130-foot cosmic mandala into solid basalt? The answer is, honestly, it's terrifying. It's called top-down excavation. Step 1. The workers literally tunneled straight into the cliff face at the exact height of the planned interior ceiling. Step 2. They carved the intricate ceiling details first, essentially propping up the mountain above their heads. Step 3. They quarried downwards. They literally stood on scaffolding and dug the floor out from beneath their own feet. They removed thousands of tons of rock through the open facade, slowly freeing up the columns from top to bottom. And this brilliantly illustrates how they survived that. To make it through that terrifying downward quarrying process, the architects had to develop these massive square lower shafts that gracefully transition into fluted circular upper columns, capped with these compressed cushions. This entire framework took the immense crushing vertical load of the Deccan basalt and distributed it perfectly. It's the only reason those massive cavernous spaces between the pillars can even exist without caving in. When you step back and actually look at the exterior of the cave, the contrast is just mind-bending. You're faced with this raw, jagged, completely untamed basalt cliff face. It's rough, it's chaotic, and yet, literally just feet behind that rough exterior lies the highly refined 36-bay mathematical perfection we just deconstructed. It is an absolute testament to human will dominating geological chaos. Which brings us to a really fascinating historical mystery. When you see structural engineering this perfect, you have to stop and ask, was Elephanta a one-off? Was this just an isolated stroke of genius by a single, brilliant architect that was never repeated? Well, let's move to the twin cave connection, because the answer to that mystery is a resounding no. This is where it gets crazy. Scholars realize that the exact same architectural and sculptural blueprint used for Elephanta Cave 1 was replicated almost exactly at Ellora, specifically at Cave 29, which is known as Dhumar Lena. We're talking about a standardized franchise blueprint here. The 36-bay layout, displacing the shrine, the massive column designs, the whole layout was meticulously copied and executed flawlessly again at Ellora. This incredible standardization of complex engineering doesn't just happen by accident. It points directly to the sheer power of the regional dynasties of the era, heavily associated with the mighty Rashtrakuta Empire. Look, the Rashtrakutas didn't just build nice temples. They mastered military, hydraulic, and structural engineering all across the Deccan. By executing these identical, massively complex rock-cut blueprints across hundreds of miles, they were flexing on everyone. It was a demonstration of unparalleled royal power, massive organizational skill, and total technical dominance over the landscape. The historical record captures the sheer audacity of this so well. I love this quote. Artists removed thousands of tons of rock by excavating downward rather than building upward, a monument to their technological inventiveness. Every time you look at the gentle face of that 20-foot Sada Shiva, remember that it only exists because an ancient engineer perfectly calculated the load-bearing thresholds of a volcanic mountain. Elephanta is, above all else, a monument to human technological inventiveness. Which leaves us with a truly staggering thought to close on. We've seen the 36-bay mandalas, the dual-axis sightlines, and the completely terrifying top-down excavations. If they could flawlessly calculate the load-bearing thresholds of solid basalt a millennium ago, entirely without the aid of modern computers, calculators, or heavy machinery, what other impossible mathematical secrets are still buried beneath India's mountains, just waiting to be reverse engineered? Thank you for joining me on this explainer, and keep questioning the world built around you.